Alright, ladies and gentlemen, welcome to part 2 of Double Word Physics Electricity. Finished off last time with a look at a single resistor sat in series. In this episode we'll have a little look at multiple resistors in series, and we'll look at some resistors in parallel as well. Okay, so on to the next one then. Let's get ourselves a little series circuit set up. So boom, boom, and kablamo, there's one battery. There we go, cross some rectangly things to make resistors. One resistor and two resistors. Now, these resistors don't necessarily need to be beside each other, but we do need to know that for a series circuit, it just means that if you consider yourself as a little electron leaving the battery or up here somewhere, then as you travel around this circuit, at no stage do you ever get a choice as to which way to go. Okay, so that's a series circuit by definition. In an exam, stick your finger on the right hand side of the battery, trace your way around, and ignoring any ammeters and voltmeters. If you never get to make a choice as to which way to go, then this is a series circuit. So let's go for a 10 ohm battery, or a 10 ohm resistor, my apologies. 10 ohm resistor, and let's make this one over here a 15 ohm resistor. Let's try ourselves on a 6-volt battery. Okay, and what we want to do here is we want to find the current that's traveling around here. The great thing about series circuits is that because the current has no choice of which way to go, at any point in the circuit the current is the same. Because it's a bit like water flowing. If the water never gets a chance to kind of change where it's going to, it's all in the same kind of pipe. So the flow at any point is the same everywhere. So for series circuits, the current is the same everywhere. So this is a series rule, and it's an absolutely critical one. Series current is the same everywhere. Okay, now this is too complicated. Even though it's only two resistors, it's too complicated for us to use V equals IR, because V equals IR, Ohm's law that we previously had, only allows us to have one voltage, one current, and one resistor. Okay, so we need to put these two resistors and we need to simplify them into a single resistor. Now for series circuits, that's quite easily done. That the total resistance, R total, help if I could spell, is equal to R1, the size of your first resistor, plus R2, and so on. You could have 10 million, no bother, just keep adding them up. Okay, so R total in this case, we will have R total is equal to resistor 1, which is 10, plus resistor 2, which is 15. So that gives us R total is equal to 25 ohms. And I'll just copy that ohm symbol out of there. See me going through all that again. Alright, so R total is 25 ohms. Now basically what R total means is that we can replace these two resistors with a single resistor. Okay, so instead of having two resistors of 10 and 15, I can simply replace that with a single resistor of size 25 ohms. Right. And then this becomes the same as the previous problem. We have one voltage, we have V equals 6 volts, we have R is equal to 25 ohms, and we want to find the current, which is an unknown. Okay. So that gives us a way into Ohm's law. So we'll scroll down a bit. Ohm's law is V equals IR, or in this case, if you use your triangle, we want I, so I equals V divided by R, which gives me a current of I equals 6 over 25. Go grab the calculator, and we do 6 divided by 25 equals 0.24, so 0.24 amps. Key thing to any form of series circuit is, or any circuit in general, is get it down to a single battery and a single resistor using whichever rules you need. Okay, so in series, the current is the same everywhere. That means that 0.24 amps is everywhere in this circuit. Here it's 0.24 amps current, here it's 0.24 amps current, here it's 0.24 amps current, here it's 0.24 amps current. And remember, current is the number of coulombs of charge passing a point in a second. So everywhere in this circuit, 0.24 coulombs of charge is passing every second. That's pretty much it for series circuits. It's just then a case of sometimes they give you current, sometimes you're given the resistance, sometimes you're asked to find the voltage. It depends. But basically, the rules are current's the same everywhere. R1 plus R2 gives you R total. Crack on with Ohm's law once you've got it simplified. Okay, and that's the end of series circuits. I'm going to stop recording here, get myself a drink, and then we'll come back and we will do parallel circuits.